Hi, welcome back to this channel. In this video, we're going to start with chapter 5.2, alkenes. And then we learn how to draw the structure and also name the alkenes. Basically, we have to name the alkene either with the straight chain or with the branch. So generally, it will consist of parent chain, not more than 10. For the cyclic alkenes, basically we will only involve the first cyclic alkene is with the 3 carbons and then the simple diene. So from the word diene here means that they will have 2 carbon-carbon double bond. Let's start with the tutorial question number 2. Draw the alkenes. So first, we have to start with the parent as we learned in chapter alkane. So we start with 2-butene. From the parent name here, we know that this parent chain consists of 4 carbon. And the 2 here is represent the position of carbon-carbon double bond, which is from the left, the second from the left. Okay, then now after we have the parent chain, then only we try to complete with the substitute. 2-methyl. As we know, methyl consists of 1 carbon, and again these 2 also represent the position of the methyl group. Now, it's time to complete the structure with the hydrogen. So from the left here, first carbon still need another 3 bonds. Second carbon already have 4 bonds. And third carbon only have 3 bonds, so means that still need another 1. While for the last carbon, from still need another 3 bonds. So this is the Lewis structure for 2-methyl 2-butene. Now let's proceed to the second one. We have parent is 1-pentene. So means that we need 5 carbon. 1, 2, 3, 4, and 5. 1-pentene means that the position of the double bond is at the first carbon and second carbon. Then now is the time for us to complete with the substitute. We have methyl and then we have 2. 1-methyl will add the second carbon, and then another methyl will be at the 4th carbon. So do keep in mind that once you already decide, you need to number from the left hand side. Make sure the substitute also need to number from the left hand side. Okay, then next substituent is isopropyl, and then is at the 3rd carbon. So as this one we know, this is the carbon. So isopropyl means that they will have 2 CH3, and then here still need another 1 hydrogen. So next we will complete this. This carbon, the first carbon from the left hand side already have 2 bonds, so need another 2. Second carbon complete with 4 bonds. Third carbon still need another bond, bonded to hydrogen. Next carbon here also need another 1 hydrogen, so they have 4 bonds, and the last carbon here need another 3 hydrogen. So this is the structure for 2,4-dimethyl, 3-isopropyl, 1-pentene. Okay, now let's continue with question C. Cis 5-methyl 2-hexene. So parent is hexene. So let's start with hexene consists of 6 carbon. So 1, 2, 3, 4, 5, and 6. So the double bond is at the second carbon. And then we have methyl group at the 5th carbon. So 1, 2, 3, 4, 5. So this is the methyl. Okay. Then now we want to draw it in the cis condition. Cis is considered as next to each other. The same group will next to each other. Okay. So now here I know that we need another hydrogen. So if I want to draw the C, so C double bond C. So from here we have 1 hydrogen. And then another group is CH3, which is 1. And then another one is CH3. Okay. Then Now this carbon will also have another hydrogen over here, so I will place the hydrogen at here. Okay, and then another bond is this part. Okay, which is C, and then CH3, CH3. So here I know I need another 2 bonds, and here I need another 1 bond. So this is the cis-5-methyl-2-hexene. Okay, proceed to question B. Trans 5,7-dimethyl-3 nonane. As like usual, we start with the parent, which consists of 9 carbon. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So the position of the double bond will add the 3rd carbon from the left. And then methyl is at the 5th carbon and also 7th carbon. So now as we know, from here the carbon at the double bond already show 3 carbon. So means need another 1 hydrogen, and this one also need another 1 hydrogen. Okay, so from here we can start with the double bond. So this double bond have 2 groups. Have 2 groups, yes, and one is hydrogen, and then another one is CH2CH3 ethyl. Since we want to draw it like trans, so for these 2 groups, either way you draw it is okay. Only when we up to the 2nd carbon, as usual, also have 1 hydrogen and another big group over here. So because we want to show trans, so the hydrogen will at the opposite side. And then for here, we try to complete first. Hydrogen, CH2, hydrogen, CH2, and CH3. So from this one here, you can connect it to CH, CH3, CH2, CH, CH3, CH2, CH3. So this is the structure for donkey. Next one is E, 4-methyl cyclohexene. So cyclohexene means that it will have a hexagon. Okay, and then where is the double bond? Because there is no specific number here, means that it is referred to 1 or any number. Any number here can consist of 1st carbon, and then methyl is at the 4th carbon. So this double bond, the carbon with the double bond will consist of consider as carbon 1, carbon 2. So this is carbon 3 and this is carbon 4 with a CH3. So this is the structure for 4-methyl cyclohexene. Next one is the F2-Methyl13 Cyclohexane Diene. So di means that there is 2 double bonds. So where will be these 2 double bonds? So these 2 double bonds will be at the 1st carbon and also the 3rd carbon. So that's why here we need to draw a hexagon first. Like just now, if this is the 1st carbon, this one will be the 2nd carbon, and this is the 3rd carbon. So it will be here. Okay, then 2nd carbon will have another methyl group. So 1, 2, 3, 4, 5, 6. 6 carbon, so cyclohexane diene. So before we continue to end this question, maybe you need to check the number of bond. So this carbon consists of 3 carbon is showing here. So means that here we still need another 1 hydrogen. Carbon number 2 here have 1, 2, 3, 4, 4 bonds. Okay, so means that this carbon have enough bond. Normally we are worried about the having extra carbon. So if like this, then we know that our structure is correct because the 2nd carbon shows 4 bonds. Okay, before we learn how to name the alkene, so based on the tutorial question number 2 here, we also notice that the parents always have longer carbon chain compared to the substituent. So for example, butene, parent 4 carbon, but substitute 1 carbon. So this one substitute 1 carbon, 3 carbon, and then the parent have 5 carbon. So parent have 6 carbon, but the substituent have 1 carbon. So for the question D also 1 carbon, but the parent have 6 carbon. So the next question, parent have 6 carbon, and the substituent have 1 carbon. So last question, substitute 1 carbon, and then the parent also have 6 carbon. So from here again, we will have the idea that when we want to name the alkene, the parent chain must be the longest and also consists of the carbon-carbon double bond. Okay, so now let's look at the first rules when we want to name the alkene based on the IUPAC name. Like just now we mentioned, select the longest continuous carbon chain and must be content of double bond. And the suffix is ene. Okay, so as we already know, the name of the alkene always end with ene. So for example, in the example 1 at the right hand side here, from the left 1, 2, 3, 4. So if this is the alkane, so we have two choices. We either can go to the right hand side or we can go down here. But because of this is alkene, so you have to consider this. The longest carbon chain might contain carbon-carbon double bond. So means that for the example 1 here, we only have one choice, which is going down. Okay, so when we going down, then we already select the longest carbon chain. Then now we go to the step number 2. Number the parent chain from the end nearer to the double bond. So previously, because of alkane does not have functional group, so we will give the lowest number to the substituents. But for the alkene or for the organic compound with the functional group, we need to give the lowest number to the functional group. So again, as usual, we have two possibilities to do the numbering. 1 from the left, 2, 3, 4, and 5. So if I number based on the the green color one, the name of the alkene will be considered 1, 2, 3, 4. Okay, 4-pentene. But if I numbering from the bottom here, 1, 2, 3, 4, and 5, if based on the red color, so the name of the alkene is 1-pentene. So in this case, we will consider 1-pentene as the parent name. After we give the parent name, then we notice here there is one substitute. So this substitute, since we already decide that we have to use the red color one, so make sure when you numbering the substitute, also need to base on the red color one. So the substitute consists of 2 carbon, which known is ethyl, and attached to the second carbon. So the name of this alkene is 2-ethyl-1-pentene. Okay, without wasting the time, let's continue with the tutorial question number 1. Give the IUPAC name for the following alkene. Start with structure A. As usual, we need to identify the longest carbon chain, which consists of carbon-carbon double bond. Okay, so we know that we can number from the left 1, 2, 3. So, and then here continue to 4. Okay. Okay, so this is the longest carbon chain. And then now we need to do the numbering. So if I number from the left here, 1, 2, 3, 4. If I number from the bottom here, carbon 1, carbon 2, carbon 3, and carbon 4. So from here, no matter you number from the left or right, the carbon-carbon double bond will add the second carbon. So this means that we can do the numbering at any position, with any color from the left or from the bottom. No, so this time if the number of the functional group, which is the carbon-carbon single bond, are similar, then we will check the substituent. Okay, so this is the substituent. If based on green color 1, the number of substituent is 2, while based on the red color, the substituent is 3. So 2 and 3, definitely 2 is the lowest. So means that in this case, we're going to name the compound based on green color. We again, like usual, we start with the parent. So the parent chain consists of 4 carbons, so it's butene. And then the double bond is at the second carbon, 2 butene. Then we only have 1 substituent, and this substituent also at the second carbon, so it is 2-methyl-2-butene. Now let's proceed to question B. Like just now we mentioned, we have to find the longest carbon chain. If the carbon chain is numbering from the left, will be 1, 2, 3, 4, and 5. However, you may try another way, which is from the bottom here, 1, 2, 3, 4, 5, and 6. So green color with 6 carbon, while yellow color with 5 carbon. So we know that this 6 carbon is the parent chain. Okay, then now means that we only have 1 substituent. Okay, this is the substituent. So as usual, we have few ways to do the numbering. If from the bottom here, 1, 2, 3, 4, 5, and 6. Or I can, from the right hand side, top right here, 1, 2, 3, 4, 5, and 6. So between these two, the position of the double bond, one is with 2 and then another one with 5. So in this case, definitely we will choose the green color one. So now we have 6 carbon, so it's hexane, and then the double bond is at the second carbon. Then now we will look at the substituent. So we are basing on the green color, so the substituent is at the 4th carbon. So the name for this alkene is 4-methyl-2-hexane. Okay, without wasting the time, now we continue with question C. So for question C, as usual, we need to identify the longest carbon chain from the left, 1, 2. We will not go down because if we go down, there is no double bond. So we have to proceed to the right. So when we proceed to the right, we also need to proceed to the right again, because when we go up, there is no double bond. So proceed to the 4th carbon and 5 carbon. So from here again, we know that the longest carbon chain consists of 5 carbon. As usual, we have 2 ways to numbering, 1, 2, 3, 4, 5, from the left to the right. How about if from the right to the left, 1, 2, 3, 4, 5. So from here again, we will notice that green color here showing the lowest number for the substituent. So from here we know that this is 2-pentene. Okay, so we erase these two first. Okay, after we know that, then we notice that we have one substituent, two substituent. Okay, both these substituent will be known as methyl because their formula are same. So it's dimethyl because I have two methyl. So we have to numbering based on the green color one here. In this case is carbon 3 and carbon 3 and carbon 4. So that's why the correct name for this compound is 3,4-dimethyl 2-pentene. Okay, proceed with the naming. Question number 1, donkey. So again, we need to identify the longest carbon chain from the left. 1, 2, 3, 4, 5. So we have to go up before because there is a double bond. So 1, 2, 3, 4, 5, 6, and 7. So this is the longest carbon chain. Consists of 7 carbon. So we will know this as heptene. Okay, but there is 2 double bonds, so we must end with the name diene. Okay, so 7 carbon is hep. So we add 1A hepta and then diene to represent there are 2 double bonds. So where are the position of the double bond? So I think definitely very obvious that we will number from the left here because carbon number 1 consists of double bond. 1, 2, 3, 4, 5, 6, and 7. So the position of the double bond is at the first carbon and the 5th carbon. So 1, 5 heptadiene. Okay, then now also here we notice that there is only one substituent. This substituent consists of 3 carbon and then with CH3 and CH3. So this one is isopropyl. So this isopropyl is at the 5th carbon. So it's 5 isopropyl 1,5-heptadiene. Okay, next proceed to question E. So again, when the structure, you can see there is a shape and then this is a hexagon shape. So we know that this is cyclohexene. So automatically, we will consider the carbon with the double bond will be the first carbon. So 1. And then we have the 2 must be anti-clockwise because the first 2 number must be consist of the carbon with double bond. So when we numbering anti-clockwise 1, 2, 3, and 4. So in this case, we can see there is 2 substituent. Okay, the first substituent is iodine and then is at the carbon number 1. While the second substituent is bromo, is at the 4th carbon. So when we have 2 substituents, we have to consider the alphabetical order. So in between B and I, B comes first, okay, and followed by I. So that's why the full name for this structure will this alkene will be 4-bromo 1-iodo cyclohexene. Okay, now without wasting the time, we continue with question F. So for the question F, from here, the structure is very obvious. It's in the form of trans. So for this case, we know that the name must we have the word trans. Okay, then now as usual, we need to identify the longest carbon chain. From the left, from here is 1, 2, 3, 4, 5, and 6. This is the longest carbon chain. So again, we need to do the numbering. If from the top here is 1, 2, 3, 4, 5, and 6. So if I numbering from the bottom here, 1, 2, 3, 4, 5, and 6. No matter I name from the top, the double bond is at the third carbon. If I number from the bottom, the double bond also at the third carbon. So for this compound, it will known as trihexene. Okay, after knowing how to draw and also name the compound, so now we proceed to tutorial question number 3, at where they mention that the name of the alkene is incorrect. You need to suggest the new or the correct name and then give the reason. Okay, we look at question A first, 2-ethyl cyclopentene. As usual, we try to draw the cyclopentene with a pentagon and then 2-ethyl. So let's say this is carbon 1 and then this is carbon 2, 2-ethyl. Ethyl is CH, consists of 2 carbons, so CH2, CH3. Okay, however, again, we need to give the correct name. So in this case, we supposedly name the, based on the name here, they name this is the first carbon and then this is the second carbon. Okay, but the correct way supposedly is this one is the first carbon and this is the second carbon, because we need to give the lowest number to the carbon-carbon double bond. Okay, and then at the same time, after that, okay, so you will say from the left as green color also 1, 2, red color also 1, 2. Then the next one, we will considering the substituent. We need to give the lowest number to the substituent. So the correct name is 1-ethyl cyclopentene. And the reason is lowest number to the substituent. Okay, now let's proceed to question B. So 3-pentene consists of 5 carbon, 1, 2, 3, 4, and 5. So from the left, carbon 1, 2, and 3, so we put here. Okay, if from the left, we numbering here. Okay, so but then if I number from the left hand side will be, right hand side based on the green color, 1, 2, 3, 4, and 5. We have 2 with 3, so 2 with the lowest number. Okay, so that's why this one supposedly will be known as cis-2-pentene. Okay, so now let's try to draw the structure for the pentene. So this carbon or second carbon already have 3 bonds, so means that there is another hydrogen. So the third carbon also have 3 bonds, so there is 1 hydrogen. Since we want to draw the cis, so we draw to first, second, and the third carbon, and then here we have hydrogen, and then another group is CH3. Well, for the other one is hydrogen, and then we still have another 2, which is CH3, CH2. So if we compare, this is 2-pentene and then this is 3-pentene. So the reason is we need to give lowest number to the carbon-carbon double bond. Okay, now we will go into the objective question, which related with the IUPAC name of alkene. Okay, which is question number 1. So from here we can see Cl and Cl is at the opposite side. So basically we know that this is trans. So option B will be out. Okay, then next we're going to identify the longest carbon chain. So based on the option here, so we can see hexene, 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 basically it's 6 carbon. So we need to identify lah. So from the left side here, 1, 2, 3, 4, 5. So this CH3 with a blanket, we know that it is a substitute. So 6 carbon. Okay, so when we look at 6 carbon here, we have 3, 2, and 4. So basically from the name here, as what we already know that the position of the double bond supposedly is at the lowest, with the lowest number. So means that for this one, we are going to do the numbering from the top here. First carbon, second carbon, third carbon, fourth carbon, fifth carbon, and sixth carbon. So 2-hexene is possible. So it looks like the answer should be C. However, we're going to check the answer. Okay, so the substituent, the chloro, come first because the alphabet C is considered. For methyl, we consider the M. So now look at the structure, the numbering over here. Chlorine, yes, at the second carbon and third carbon. And then the methyl group is at the fifth carbon. So trans 2,3-dichloro 5-methyl-2-hexene is the correct name. Okay, so in this video, we already know how to draw the structure of the alkene and also name the alkene. So in next video, we are briefly going to discuss the boiling point of alkene based on the cis-trans condition. Okay, thank you and see you in next video. Bye bye.